So I thought I was going to get to the FST 3253 and the transformers in the last video, but it's kind of, the video was getting long, so this is a separate video where I'm going to put together the quadrature sampling encoder. But one of the things I did notice as I was kind of preparing is I've actually put the wrong toroids in here. So these are supposed to be 37 sixes. So 6 is the core type, and that's yellow. 37's the outside diameter in hundredths of an inch. So 37 sixes and 36s, if you look at them separately, they kind of look similar. So I'm going to have to also replace these two with these 37 sixes, and then these 36s actually go into the quadrature sampling encoder here and here. So I'll get on with that and be right back. Well, unfortunately, while I was winding it, I crossed two of the wires over, so I'm going to have to unwind it and rewind it. Anyway, I'll get on with that. So, just like the binocular core that we did earlier, I have a primary and a secondary consisting of two bifillers. So the next step is to figure out which is which. So I've kept the primary long, so that's easy to identify, and that should have continuity. You can see it does. And now what I've got to find out is which one of these wires goes to which one of these wires, and then I'll rearrange it so that it's easier to put on the board. So let's try here and here first. There's no continuity there. Oh, there we go, there's continuity. So these two go together, and these two should go together. There we go. So there's the primary winding right here. There's one of the secondaries, and there's the other of the secondary. All right, well, I'll just make sure that they don't have any cross continuity here, and I don't. And so we'll get on with showing where that goes on the board. Okay, so we have the board here. So the two secondary windings are here, They're actually referred to the primary windings in the kit, so let me do that. So the two primary windings are across here and across here, and then this is the single secondary winding. So this is where the long wires go, and then the two pairs go one pair across here and one pair across here. So let's get that installed. Got to hunt down my tweezers now. They're around here somewhere. Aha, found them. So let's get that installed now. Let's start with the single secondary. And that's in. And now the two pairs of primaries here. I think it's going to be easier coming at it from the other side. There's one pair. Here is the other one. Quick check, you can see what's going on here. Oops. It's kind of fiddly, this part, but okay, just push it down a little bit. And then I'll flip the board and pull them through. So there's the windings there. Now again, like the binocular toroid, the primary windings, the pairs of primary windings are actually connected together on the circuit. So you really need to establish which of the primaries and which of the primary pairs go together before you install it. But in any case, let's just test continuity there and check that out. Let's move the camera back a bit. Okay, so I should have continuity across these two, which I do. And then continuity across, actually I need to pull this one through a little bit more. There we go, so I should have continuity across these two. Which I do. See, I have continuity across the pairs of secondaries now, so the pairs of primaries now, so I should have continuity here. So that's that installed. Let me just see if I need to pull that through a bit further, and I do. A little bit crooked. One of the other things that you have to watch out for, and it's going to be very difficult to see this on the camera, get a bit of light down here so we can perhaps see it better. You've got to make sure that you don't touch the primary windings together, and I can see that they're not touching, so in other words, you want to make sure this primary doesn't come in contact with this primary. So that looks good. I will solder that in now. one final test here. Testing continuity. So I should have continuity across here. So this is the single secondary winding here. And I do. And I should have no continuity to either of the primaries. Whoop. Sorry. Let me just move that around properly. I'm actually touching this guy here, which is grounded, so that's not the right one. So I should have no continuity to either of the primaries. And you can see here, this there's a little track that goes right from here, from this winding of the primary to the other winding of the primary, so you really can't tell after you've installed it which is which. So you really got to figure it out before you install it. Anyway, that's that transformer T2 installed. I'll install the L1, which I've previously wound, and we will continue. So the FST 3253 Mux T2 L1 are all installed, and we can now start injecting some signals and observe results. So as before, I'm using my signal generator to emulate the I and the Q signals that would otherwise be coming from the SDR software. So just zooming in on the setup there, you can see I've got channel 1 and channel 2 both enabled. Both are outputting a 3 kilohertz signal at 400 millivolts. The channel 2 signal is 270 degrees offset from channel 1. So both these signals are actually in quadrature. So just panning back to the schematic, I have my local oscillator set to 14.05 megahertz, and I'm probing right here on the circuit. So the signals from the multiplexer come out of here. They get added together through this transformer here, and then they flow down here through to this capacitor here, and that's where I'm probing. So we should be able to see by varying the phase of channel 1 and channel 2, either the upper sideband or the lower sideband be generated. So let's move back to the oscilloscope, and we'll enable the transmitter. And you can see there that after the counter settles down, you can see there that I'm actually getting a 14.053 megahertz signal out of the radio. So I have my local oscillator set to 14.050. I'm injecting those quadrature signals, 3 kilohertz each, and I'm getting the upper sideband at 14.053 megahertz. Now you can see if I adjust the phase of channel 2 to 90 degrees, what I'll get is the lower sideband. So you can see as that settles down, let me zoom in on the oscilloscope, and you can see now I'm getting 14.047 megahertz. So that's the lower sideband. And that was achieved purely by adjusting the phase of the I and the Q signals simulated coming out of my signal generator. Now the phase is at 90 degrees. So 270 degrees generated the upper sideband, and 90 degree phase shift generates the lower sideband. So we can actually see the upper and lower sideband a little more graphically if we move into the frequency domain. And I'll just connect it up to a spectrum analyzer. And so I had some scope probes fall off at an inopportune moment. But just panning over to the spectrum analyzer, you can actually see the generated signals. So if I turn on and enable the transmitter again, you can see that the 3 signals generated. So the signal on the left is the lower sideband signal. Let me just move the marker so that we can see the frequency there. So if I just get that aligned with the top there, 14.047 megahertz. So that's the lower sideband generated. So the signal in the middle there is the remainder of the carrier frequency at 14.050. And then you can see there's a little spike on the right-hand side that's the remainder of the upper sideband that hasn't been completely removed. So again, if I change the phase of channel 2 with respect to channel 1, let me go back to 270 degrees. You can see now the upper sideband is present. Upper sideband at 14.053 is the remains of the carrier, and then the lower sideband is nearly completely suppressed there, 14.047. So that basically confirms that the I and the Q processing of the radio is complete. The following steps are the driver transistor, which is a 2N2222 transistor, and then that flows into the push-pull configuration that I mentioned earlier, where we have two BS170 FETs in a push-pull configuration. So that'll be in the next video, and that will hopefully, I think, be the final video in the series. We'll take it all the way through, demonstrate the output, and then hook it up to the SDR software on the computer.